Before you watch this video, make sure you watch the two videos that I've done already. So the one that says G equals F over M and Newton's law of gravitation. Alright, so gravitational field strength for a point mass 18.3. So we did say that the gravitational field strength is force per unit mass. So in this case, force is measured in newtons, mass is measured in kilograms. And from Newton's law of gravitation, we learned or we saw that F is equal to minus G times M1 times M2. G is the gravitational constant. Remember that G is not the gravitational field strength. In this case, G is 6.67 times 10 to the minus 11. 6.67 times 10 to the minus 11, and R divided by R squared, where R is the distance between the two objects. So we're going to put the equation for F back into the top equation. So then therefore we get one of the m's will cancel. So therefore the gravitational field strength is equal to minus. Now remember, the minus just means it is attractive. So G is equal to minus the gravitational constant, which is 6.67 times 10 to the minus 11, times the mass that is creating the gravitational field. And then you divide by the distance between the two objects. So have a look at this one here.
Alright, so we can see that G is equal to minus Gm over R squared. And you know that G is the gravitational constant, it's not the gravitational field strength constant. So from the equation you can see that G is proportional to M, G is proportional to 1 over R squared, and if we do a graph of G against R, that is the graph for this one, and if you do a graph of G against 1 over R squared, you get a straight line, but it will be a negative gradient.
And in a uniform gravitational field, the gravitational field strength does not change. Now the word uniform means that they're equidistant, so the field lines are equidistant and parallel. And this is near the surface of the Earth, where G is almost fairly constant, and this can be considered uniform, approximately uniform, and at the top of the mountains the distance increase is negligible. So let's just read through the question. So the radius of the Earth is 6,370 kilometers. Its mass is 5.97 times 10 to 24 kilograms. You've got a 75 kilogram astronaut in the International Space Station. It orbits at a height of 405 kilometers above the surface of the Earth. Calculate the magnitude of the gravitational field strength at this altitude and the magnitude of the weight of the astronaut. And this was my working out.
For this question, let me just read it out. So the radius of the Earth is 6,370 kilometers, and it has a mass of 5.97 times 10 to the 24 kilograms. A 75 kilogram astronaut in the International Space Station orbits at a height of 405 kilometers above the surface of the Earth. Calculate the magnitude of the gravitational field strength at this altitude and the magnitude of the weight of the astronaut. Now I have written 6 times 10 to 24 kilograms, but in the book it does say 5.97. Right, so first we need to look at the distance from the center of the Earth to the International Space Station. So here you have 6,370 kilometers, and you have the distance 405, so you add them together, so you should have 6,370 add so you end up with 6,775 kilometers. And then what do you do? Now, the question is asking for the gravitational field strength. So, from Newton's law, you know that F is equal to minus G m over r squared. And you know that the gravitational field strength is force per mass. So, one of the m's will go. So, F is equal to minus. Now, this m is always about the mass that is creating the gravitational field. So in this case, this m is the Earth, because it's the Earth that is creating the gravitational field, So G is 6.67 times 10 to the minus 11, and then I'm using 6 times 10 to the 24, and then divide that by 6775000 squared. And I got 8.7188. So that's roughly 8.72. Remember, the gravitational field strength, it could be because it's force over mass. So that's you can write down as Newton per kilogram, or you can write down as an acceleration. So the answer was 8.72. So the answer was 8.72. Now, if you use the answer in the if you used the answer that was given, sorry, if you used the mass that was given, 5.97 times 10 to 24, you would have got 8.67. Now, let's just use this one. So if we used 8.72, that is G, the gravitational field strength, not the gravitational constant. Remember the question, it says the mass was 75 kilograms. So the weight would be 75 times 8.72. And so I've used 8.7188 times 75, and I got 653.91. And so therefore I've got 654 newtons to 3 significant figures.